So let's begin by taking some notes down, okay? This whole worksheet, this front side is to graph reciprocal functions. We gotta know what a reciprocal function looks like. And I would probably write this all the way to the left. I would write it over here on your paper. What is a reciprocal function? Y equals fraction, A is up on top, and then you have x minus h plus k. Now, the A value is exactly the same as the A value on a parabola. It tells you it gets vertically stretched or compressed. If it's negative, it gets reflected over the x-axis. And the h, just like on vertex form of a parabola, is a shift left or right. You think opposite of what you see. And the k is a shift up or down, and you take it for what it is, okay? Now, once you have this, once you're familiar with this form of reciprocal functions, which are hyperbolas, you need to be able to state the vertical asymptote. Vertical asymptote is running up and down, and it's going to be the line x equals h. So x equals h, and it's going to be opposite of what you see here because of the minus sign, right? So if you have x minus 5, the vertical asymptote is x equals 5. If you have x plus 3, the vertical asymptote is x minus 3, or x equals negative 3. It's always opposite of what you see. Then the horizontal asymptote is simply y equals k. Horizontal is left and right. It's going to be the horizontal line crossing the y-axis at that value k. So that's how you start graphing, by identifying your h and your k, which is your vertical asymptote up and down, horizontal asymptote left and right, which is y equals k. And then after that, once you have your asymptotes, then you look at your a value, okay? If your a value is positive, it's going to behave like a line that has a positive slope, which is lower left from the asymptotes and upper right from the asymptotes. Now, again, if the a value is negative, I didn't write that down, but it's pretty, I hope you understand that if it's negative instead of positive, it's going to behave like a line that has a negative slope, not positive slope, which would be upper left and lower right, okay? It'll make more sense once we actually start graphing. And now, if you want precise points, you want more coordinates that are exact, that are precise, you could just do an XY table and plug in some X values that are like 1 unit away from the vertical asymptote, okay? So I want to pause it right here so you guys could copy this down. Okay, so let's use these notes, let's use this knowledge to be able to graph without decimals, obviously. Now, this is the parent graph of all reciprocal functions, which are hyperbolas. It's nice and easy. We've already, if you think about the notes, it says x minus h, which there is no minus h, so you could put a minus 0 if you want, and the k value is plus 0 if you want. In other words, the vertical asymptote is x equals the h value, which is 0. So you go to the x-axis, you go to 0, you draw a vertical line right through it. I always use a green dotted line. Obviously, you drawing that line is kind of pointless because it's on the y-axis itself. You know that that's going to be the asymptote. The horizontal asymptote is going to be, it's going to be y equals the k value, which in this case is 0 as well. So that'd be on the y-axis at the y value of 0, which is right here, and you draw a dotted line right through that y value of 0, horizontal asymptote, okay? So from there, what do? Well, you look at your a value. Your a value in this case is positive 1, okay? So it's going to behave like a line that has a positive slope. Any line that has a positive slope from left to right is going to be going up. Any line with a negative slope from left to right is going to be going down. So right here, the a value is positive. From left to right, it's going to be going up. So that means it's down here, lower left, and up here, upper right from your asymptotes, which in this case, the asymptotes happen to be the x and y axis. So you just draw your graph like if it's touching the asymptotes, even though, you could draw it on it, but you know it never actually touches, just infinitely approaches. And then it's going to have to curve down and make it look like it's touching down here, but it got to curve like that, right? Now, the question is, if you want it to be exact, then you probably want to make a input-output table. Now, what do I mean by that? XY table. And it's as easy as plugging in a value that's on one side of your vertical asymptote. So you could plug in this x value, which is negative 1. So you could plug in a negative 1 on your x and see what you get out for your y. So if you plug in a -1 right there, what's 1 divided by -1? It's -1. So the actual location of an actual point, a precise point, is -1, -1. -1, -1. Put a dot right there at -1, -1. And that's where your graph should have gone through. So as you can see, it wasn't perfect. Just make it go through that point. And now it is perfect, okay? This is a precise point, -1, -1, okay? And like we said, it's down here lower left, which means upper right, okay? So we're going to do the same thing up here. You're going to draw it like if it's actually touching, but we know it never actually touches. It just infinitely approaches. So you could draw it like it's touching, but just know that it doesn't actually touch, okay? Now, if you wanted a precise point, which it looks like it's right there, but if you wanted to be precise, you could plug in, we already plugged in an input that was 1 unit to the left of the vertical asymptote. You could plug in an input that's 1 unit to the right of the vertical asymptote. So you could plug in the x value of 1, maybe in black, stay color coordinated. And if you plug in the value of 1, 1 over 1 is 1. So if you plug in a 1, you get out a 1, and that's a location 1 on the x, 1 on the y, and that is that perfect point right there. Yay? All right, so that's the process of graphing, okay? If we look at this next one, what's the difference between the first one and the second one? This other one is negative, which means that your a value is negative, which means that just like in parabolas, when you had an a value that was negative, right here, this a value that's negative is going to cause a reflection over the x-axis, right? So once again, you know that your vertical asymptote is x equals the h value, which in this case is -0, and the horizontal asymptote y equals the k value plus 0, so that's going to be y equals 0. So your vertical asymptote is at the x-axis at 0. You draw a vertical line right through it. The horizontal asymptote is y equals 0. Go to the y-axis, go to 0, draw a horizontal asymptote right through that y value of 0. And it will cause a reflection over the x-axis. Once again, the notes I gave you say that if your a value is negative, it's going to kind of behave like a line that has a negative slope. From left to right, it's going down, which means it's going to be up here, upper left from your asymptotes and lower right from your asymptotes. So you simply draw it and draw it. Well, that's kind of ugly, but you get the idea, okay? Now, if you wanted precise points, just like it says on our notes up here, if you wanted precise points, use an XY table. But after you do this a couple of times, you're going to notice something. If you do an XY table and you plug in a value that's to the left of your vertical asymptote, like you can't plug in the vertical asymptote. This x value is 0, that's an asymptote. If you plugged in 0, it's going to be undefined. If you do it with the calculator, 1 divided by 0 is undefined. So I'm going to plug in one that's on the left side of the asymptote and one that's on the right side of the asymptote. When you plug in one on the left side, -1, that's the input, -1, what will it give us? Well, when you plug in a -1 right here, it's going to be a -1 divided by a -1. And -1 divided by -1 is +1, and that's a location, -1, +1. So that would be a precise point right there. And on my sketch, it looks like it actually went through there, so that's perfect. Now, I'm going to plug in, since I already plugged in 1 unit to the left, let me go 1 unit to the right. Let me plug in the x value of 1. And if I plug in that x value of 1, what do I get? Plug in a 1 right there, you can get 1 over 1, but it is negative, so it is -1. So when you plug in a 1, you get out a -1. So if you go 1 on the x, -1 on the y, there's a precise point. Now, I guess my sketch wasn't perfect because it should be going through that point right there. So that's a little bit nicer, making it go through that point. That's if you want precise points. But then again, after you do this a couple of times, you're going to notice that if your a value is 1 or -1, that means that it doesn't get vertically stretched or compressed, okay? Now, what does that mean? That if you go 1 unit away from the vertical asymptote, it'll be 1 unit away from the other asymptote. If you go 1 unit away from the vertical asymptote, it's 1 unit away from the other asymptote. Same thing here, a value is 1. 1 unit away from the vertical asymptote, you're at 1 unit away. 1 unit away in the other direction, 1 unit away of the other vertical horizontal asymptote. So if you were to put a 2 up here, the a value would be 2. It would vertically stretch it by 2. So what would that mean? instead of 1 unit away and being 1 unit away, if you vertically stretch it by 2, it's going to be up here at that point, if that were a 2. Does that make sense? I hope so. So if this were a 2, it would be 1 unit away, but instead of 1 unit, it's 1 times 2, which would be down here, if that were a 2. What if it were a 3? Well, then it'd be 1 unit away and then 1, 2, 3 right here. Okay? Same thing, 1 unit away would be 1, 2, 3. The dot would be up here if that 1 were a 3. So that's where the vertical stretch or compress comes into play. When your A value is other than 1, it actually gets stretched or compressed. And of course, you could always graph these on Desmos to double check your answers. But on the actual quiz, you're not going to be able to use Desmos. You're going to have to understand this. So again, let's jump to something more interesting. Let's go to something like there is no number. Let's go to the g of x function. By the way, you're probably thinking, what? G of x, what does that mean? You have y's, you have f of x's, you have g of x's. The f of x, the g of x, the y, those are just the names of the functions that we're looking at. In this case, we're going to call this one g of x. So how do you start graphing? You start by identifying your asymptotes and graphing your asymptotes. So what's the vertical asymptote? What's the vertical asymptote? X equals -1, the opposite of what you see here. Remember x equals h? It's the opposite of what you see there. So what does that mean? It's a vertical line crossing the x-axis at -1. Go to -1, draw a vertical line right through there. I always do a green dotted line. And then I need my horizontal asymptote. I want to abbreviate horizontal asymptote. That's y equals what? Y equals k. What is my k value? 2. So y equals 2. You don't think opposite right there. You take it for what it is. So you go to the y-axis. Here's the y. You go to the y value of 2, and you draw a horizontal line right through it. So you draw a horizontal line, dotted line right through it like that. Okay? So now we know that our graph has to be along these asymptotes. But it might be up here and down here, or it might be down here and up here. It all depends on your A value, if it's positive or negative. Right here, the A value is negative, which means it's going to behave kind of like a line that has a negative slope. From left to right, a line that has a negative slope is going down. So it's going to be upper left of the asymptotes and lower right of the asymptotes. Are you with me? Okay, so you know it's going to be up here, and it's going to come down, curve, and it's going to be going this way like that. But the question is, how much does it curve? Remember, it's going to be, since there's no stretch, it's just the A value of -1, 1 unit away is going to be 1 unit away, so it's going to be right here. And that's just like an observation, a shortcut. You don't have to do an XY table. It just curves through that point, comes out this way, curves that way, along that asymptote. And likewise, because there's no vertical stretch, it's going to be 1 unit away in the other direction of the vertical asymptote. 1 unit this way is going to be 1 unit this way, and that'll be an actual coordinate right there. And you draw it like if it's actually touching, but it has to pass through that point, and then it curves this way, and you draw it like if it's actually touching. That's a precise graph right there without using Desmos. Okay? Now, if you were to make an input-output table, and if you look at your asymptote, the vertical asymptote's at x equals -1. Obviously, you don't want to plug in a -1 because it's an asymptote. It's undefined. Plug in a -1. -1 plus 1 is 0. You can't divide by 0. So, being that this is a vertical asymptote, I would plug in a value that's on 1 unit away to the left. So 1 unit away to the left is the input -2. So if you do plug in a -2, plug in a -2 right there. Think about it. -2 plus 1. -2 plus 1 is -1. And -1 on top divided by a -1 on the bottom is +1. And +1 plus 2 is 3. So the actual location of the perfect point of this graph is -2, 3. So from the origin, go -1, 2, 1, 2, 3, and bam, there's that dot. But again, we already knew that because I explained that the pattern will always be when your A value is 1, it's going to be 1 unit away and 1 unit away. Now, if that would have been a 2, it would have been 1 unit away and then 2 units away. If that would have been a 3, 1 unit away and 3 units away. I hope that makes sense. Okay. Likewise, if I wanted to plug in a value to the right of that x value of -1, that'd be plugging in 0. And we already know when I plug in 0, I want to get out +1 because I see it right there. I already understand the pattern. So if I do plug in a 0, 0 plus 1 is 1. -1 divided by 1 is -1. -1 plus 2 is +1. So plug in a 0, get out a 1. Go to the location 0, 1. There it is. We already knew those dots without using an input-output table. Does it have to be perfect? No. But you definitely need to know that it's along this side of the asymptotes and this side of the asymptotes. Let's do one more. Let's do one that actually has a vertical stretch. Which one do you guys want to do? Both of these have a vertical. This one has a vertical stretch of 2. This one has a vertical stretch of 3. Which one would you like to do?
3.
The 3? Okay. So let's go to 3 and let's start graphing this. What's the first step on graphing any of these? Identifying the asymptotes. The vertical asymptote is x equals h. What is h?
1.
Yep, +1. So go to the x-axis. Here's the x-axis. It says x right there. Go to +1, and you're going to draw a vertical line right through that x value of 1. How about the horizontal asymptote? That's y equals the k value, which is 2. Okay? So go to the y-axis. Here's the y. It says y. Go to 2 and draw a horizontal line right through it. So here's 2 on the y. Horizontal line, dots. I always do dotted lines for the asymptotes. Okay, now, is my graph going to be upper left, lower right of the asymptotes? Or lower left, upper right of the asymptotes? Well, you got to look at your a value. Your a value is a -3. Okay? It's negative. You don't even have to look at the 3. It's negative, which means that it's going to behave like a line that has a negative slope from left to right. It's going to be going down. So obviously we're talking about upper left and lower right. Are you with me? Okay, so if it's upper left and lower right, you know that it's going to have an arrow up there and it's going to have an arrow over here. Okay, but we want it to curve. Now, if the a value was 1, then the pattern is 1 unit away from the vertical asymptote, 1 unit away from the other one to be here. But the a value is not 1, so it's not here. What is the a value? 3, which means that you need to go 1 times 3. So it'd be 1, 2, 3. It'd be up here, actually. So this is actually kind of off. It would be up here. Okay? So let me go back and erase. I can't erase. Let me white it out, I guess. Because that's our dot if we want it to be perfect. So our graph would be something like this, curving that way. Make sense? And of course, it's going to be down here as well. You draw it like if it's on there. Over here as well. Draw it like it's on there. And again, if it were a value of 1, which it's a 3, if it were a 1, 1 unit away from the vertical asymptote, 1 unit away. But because it gets vertically stretched by 3, it's not 1 unit away and 1 unit away. It's 1 unit away and then times 3. So it'd be down here at that point. Solid dot there. That one's a solid dot up there. So you're going to make your graph kind of go through that point. So probably white that out. And that would be your graph. Now, of course, you could verify these points by going to an input-output table and plugging in some values. So like if your vertical asymptote is at x equals 1, you don't want to plug in a 1. You can plug in 1 to the left of it, which is like 0. So if you plugged in a 0, just to verify, if you plugged in a 0 right here, 0 minus 1 is -1. 3 divided by -1 is a -3, but with another negative, it's actually +3. And then +3 plus 2 is 5. So you get out a 5 when you plug in a 0. And that makes sense because the location 0, 5 is right there on that black dot. But we got that from the pattern, knowing that it got vertically stretched by 3. But you could have used the input-output table if you wanted to. Likewise, over here, you could have said, well, I don't want to plug in a 1 because that's the asymptote x equals 1. but I could plug in a 2. So you could plug in a 2 right there to get that other point. And if you did plug in a 2, 2 take away 1 is 1, and 3 divided by 1 is 3, and 3 with the negative is a negative 3, and negative 3 plus 2 is a negative 1. So if you go 2 on the x, negative 1 on the y, that's that perfect point right there. Again, we don't have to do this if you understand the pattern. The pattern is, if it were a 1, then it's 1 unit away, 1 unit away, 1 unit away, 1 unit away. But it's a 3, so that 1, 1, it got vertically stretched by 3, so it becomes 1, 2, 3. There's your dot. Instead of 1, 1, it's 1, 1, 2, 3, because it got vertically stretched by 3. I hope that makes sense. Let's take a look at the backside. So you guys could work on the rest of these, and the answers are posted on Google Classroom. If you look at the backside, right here we're describing transformations. So if you're like, oh, what? I'm confused. I hope you guys remember parabolas. Parabolas were pretty simple. If you could identify the a value and then identify the h and the k, then you know that it gets either, if it's a negative, it would get reflected. And then after that, if you have a number right here, like the number 2, that's a vertical stretch of 2. And then you think opposite of what you see here, and that's your shift to the right, because it would be a positive 3. And the k is a shift up or down. So on this guy, you would say, what's the first thing that happens? It gets vertically stretched by 2. If it would have been a negative 2, I would start by saying it gets reflected over the x-axis, then it gets vertically stretched by 2. But it's a positive 2, so there is no reflection. I just say it gets vertically stretched by 2. And then after that, the second thing that happens is the shifts. Shifts according to h and k. Squiggly underline on the h because you think opposite. So you say it shifts 3 to the right and 4 units up. And that's it. That's the description of the transformation from the original parabola to this new parabola, right? And this is exactly what we're doing today. Same exact things with your a, h, and k. If your a is negative, you would start by saying it gets reflected over the x-axis. And then if you have an actual number here, it's a vertical stretch by whatever that number is. And then you think opposite on h, and that'll be the shift either left or right. Think opposite. And the k is the shift up or down. So when we look at number 2, if you look at that number 2 right there, it's the same exact a, h, and k. So it's going to be the same exact transformations. No reflection because it's not negative. It does get vertically stretched by 2. It does shift 3 to the right, and it does shift 4 up. So, So it's pretty easy if you understand a, h, and k. So how about let's do number 6. From your original parent graph to this new one, what are the changes? What are the transformations? We're going to start with number 1. What is number 1? I see a negative out here. So what do we say about that? That it gets reflected over the x-axis. Reflected over, reflected across, whatever you want to call it. Then you move to the actual numeric value, which is 2. That causes a vertical stretch of 2. And then after that, you're going to talk about your shifts. So it shifts where and where? It shifts 3 to the right because you think opposite. So 3 units to the right. And that k value, take it for what it is. Don't think opposite. And 1 unit down. So those are all the transformations from the original to this new one, and it's all based off of the a value being negative 2, the h value being positive 3, and the k value being negative 1. Okay. So I'm pretty sure you guys could get the rest of these and check your answers on Google Classroom. Now for the last one, this is great. It makes you think, they want you to create one of these reciprocal functions that will not cross through quadrant 1 and create a reciprocal function that will not cross through quadrant 2. So let's do number 10. And let's start by just sketching an XY plane, because you got to first know where your quadrants are at. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we do not want it to go through quadrant 2. That's what it says on number 10, right? So you don't want any of your graph touching any of this area, okay? So I'm just going to highlight it so we completely avoid that quadrant, okay? So if you wanted to graph, how do you start graphing? You start with your asymptotes, right? So obviously you want asymptotes that are nowhere in this highlighted area, nowhere in quadrant 2. So somebody give me a vertical asymptote that's not touching that highlighted area, that's not in quadrant 2. X equals what? Just the vertical asymptote. X equals, give me a number. 2. Okay, so if you say x equals 2, if you say that your vertical asymptote is at x equals 2, then you could go to 2 on the x, and you could draw a vertical asymptote, right? Now, give me a horizontal asymptote that will not touch that quadrant 2. -1, perfect, okay? So you go to the y-axis, go to -1, and draw a horizontal line right through there, okay? So you would say horizontal asymptote is y equals -1. And of course, you could have picked -3, -4, but you know, these are perfect. You guys gave them to me, perfect so far, okay? Now, what kind of a value would I want to avoid at all costs this area? A positive one. Because a line with the positive slope from left to right goes up. A line with the negative slope from left to right goes down. So from left to right, if the a value is positive, it's going to be down here and up there from your asymptotes. So you want your a value to be positive, and you could just say +1, right? And that would produce this graph right here. And that for sure will messed up. That for sure will never touch this highlighted area, okay? Now, if you did it negative, then it would be up here and down there, and maybe it does cross through there, maybe not. But to be on the safe side, making your a value positive from left to right, it's going up like a line. It's down here and up there from your asymptotes, and that's the graph. Now, we still haven't created the function, though, but by us thinking through it and drawing it, we now know that the vertical asymptote, x equals 2, that's technically your h value, and the y equals -1, that's technically your k value. And of course, a, we said it was positive, so +1. So now that you know your a, your h, and your k, now you could actually write your reciprocal function. Y equals a fraction. A is +1. You don't need to put the positive sign. On the bottom, you have x minus h, which in this case is 2. And then you have the plus k at the very end, which in this case is -1. So you didn't have to put a plus -1. You could have just put a -1 right there. And this is the answer to that question, to create a reciprocal function that will not cross through quadrant 2. So with that said, you guys could think through and do the same one, number 9. And this video is already long enough, but I think this is great practice for you guys to really understand 8.3. And we are going to have a quiz on this stuff this week. So please finish this worksheet, check your answers on Google Classroom, and this video will be uploaded later to Google Classroom.